Welcome to section 9.3. We're going to be working in the complex plane and look at a very popular and very helpful theorem, de Moivre theorem. We'll plot points in the complex plane. This is something that you will be looking at in the text and in your homework. We won't specifically be doing it in lecture. Convert a complex number between rectangular, polar, and exponential form. We are going to do all three. Find products and quotients of complex numbers. Use our popular theorem, and find complex roots. So, complex numbers are the other numbers. When you've been learning your whole life about real numbers, these are the complex numbers. So these are those imaginary numbers. We have the I involved. We're going to be working with those this section. First, let's write each complex number in polar form and exponential form. And of course, we will be using our radians. Make sure that if you're throwing anything in your calculator, it is in proper radian form. -9 plus 9i. Well, this tells us that x is -9, y is 9. Our form here, x plus yi. The first thing we're going to do, because if we want it in polar form is r theta. So we need an r and we need a theta for that one. So we need our r, and r is x squared plus y squared, and we take the square root. So this is going to be the square root of 81 plus 81, which is the square root of 162. Next, we need theta, so let's find cosine theta is x over r, which is -9 over root 162. Again, we're going to get rid of that root on the bottom. Root 162 over 162, we have -9 root 162 over 162. And this simplifies to -√2 over 2. If you use your square root knowledge, fraction knowledge, you can reduce this down to -√2 over 2. Sine theta is y over r, which is 9 over root 162. Same thing. Rationalize that denominator, and we will have positive root 2 over 2. And when cosine is -√2 over 2 and sine is positive root 2 over 2, that tells me that theta is 3 pi over 4. That I know from my unit circle. So now that I have all these things, we'll write it in polar form first. So we'll have r, which is root 162, cosine theta, 3 pi over 4, plus I, sine theta. And that is our polar form. Exponential form, we have r, so we have root 162, e raised to I, and theta, 3 pi over 4. Okay, let's do another. 4 minus 4 root 3i. This tells us x is 4 and y is -4 root 3. So if we want to find r, then we have 4 squared plus -4 root 3 squared. Take the square root of it. That gives us 8. So excited about that. Next, cosine theta, x over r, 4 over 8, 1/2. Sine theta, y over r, -4 for root 3 over 8 is negative root 3 over 2. So when cosine is 1/2 and sine is negative root 3 over 2, that tells us our theta is 5 pi over 3. So our polar is r, which is 8, cosine theta, so 5 pi over 3, I, sine theta, which is still 5 pi over 3. And then we turn that into exponential, which is 8e to the I theta, which is 5 pi over 3. Very nice. Next, we have write each complex number in rectangular form. Our first one, 2 times cosine 11 pi over 6 plus I sine 11 pi over 6. The first thing I'm going to do is I'm going to find out what these are. So what is the cosine at 11 pi over 6? Well, that is root 3 over 2. And what is sine at 11 pi over 6? That is negative 1/2. And this is all being multiplied by 2. So what that does is it honestly just multiplies all those denominators off. So we're left with root 3 plus, actually it's a negative, so we're going to do root 3 minus I. And that's it. Next we have 0.3 times cosine of 4 pi over 3 plus I sine 4 pi over 3. Same thing, I'm going to find out what these values are. What is cosine at 4 pi over 3? It's negative 1/2. And what is sine at 4 pi over 3? It's negative root 3 over 2. This is all being multiplied by 0.3. So first we have 0.3 times negative 1/2. That gives us negative 0.15. 0.3 times negative root 3 over 2 gives us a negative 0.26. So we have negative 0.1515 minus 0.26i. Okay. And then we have products and quotients. So we want to find z times w if z is 8 times the cosine 11 pi over 18 plus I sine 11 pi over 18, and w is 4 cosine pi over 18 plus I sine pi over 18. Let's start with z times w. So we're going to have 8 times cosine 11 pi over 18 plus I sine 11 pi over 18. That's times 4 cosine pi over 18 plus I sine pi over 18. Now that we have it written out, let's put it in exponential form. So we have 8e to the I of 11 pi over 18 times 4e to the I pi over 18. We can use exponential rules. 8 times 4 e to the I 11 pi over 18 plus pi over 18, which gives us 32 I. We have 12 pi over 18, which would be 2 pi over 3. And so this would give us 32 cosine 2 pi over 3 plus I sine 2 pi over 3. So that's our product. if we find the, I think we can start it up here, z over w, let's start by writing it out. So we have 8 cosine 11 pi over 18 plus I sine 11 pi over 18 over 4 cosine pi over 18 plus I sine pi over 18. Exponential form, we have 8e to the I 11 pi over 18 over 4e to the I pi over 18. And we can use our exponential properties. So we have 2e to the I 11 pi over 18 minus pi over 18. That gives us 10 over 18, so we have 5 pi over 9. This will give us 2 cosine 5 pi over 9 plus I sine 5 pi over 9. Okay, that's our quotient. Next up, we want to write this in standard form, a plus bi. We have 2 times cosine 4 pi over 9 plus I sine 4 pi over 9, and it's all cubed. So what we'll do first is rewrite the inside in exponential form. So we will have 2e to the I 4 pi over 9, and this is all being cubed. Now we can use our exponent properties. So we will have 2 cubed e I, and we have 3 times 4 pi over 9. The 3 and the 9 will reduce. So we have 8 e to the I, and we will have 4 pi over 3. So if we rewrite that back, we'll have 8 cosine 4 pi over 3 I sine 4 pi over 3. And we want it in a plus bi form, so we're going to have to find out what these values are. We have 8 cosine of 4 pi over 3, that is negative 1/2. And sine of 4 pi over 3 is negative root 3 over 2. So if we multiply these by 8, we will get negative 4 minus 4 root 3 I. And we did it. We cubed that. The last one we have, find the complex cube roots of negative 4 in polar and rectangular form. I'm going to rewrite this. We have negative 4 plus 0i, which tells me that x is negative 4, y is 0, so r is the square root of negative 4 squared, which is 4. My cosine x over r is going to be negative 4 over 4, negative 1. And my sine is y over r, 0. So when cosine is negative 1 and sine is 0, that tells me my theta is pi. So we have z 4 cosine pi plus I sine pi, In exponential form, this is 4e to the I pi. So, using our theorem, we have z to the k, or z sub k, 3, the cube root of 4, e to the I, 1 over n, so 1/3, pi plus 2 k pi. And the k is going to get us all of our roots. We're looking for the cube roots, so we're looking for 3. So first we'll start with when k is 0. We have the cube root of 4, e to the I, 1/3, pi plus 0, so just pi. So pi times 1/3, that will give us the cube root of 4, e to the I, pi over 3. When k is 1, we'll have the cube root of 4, e to the I, 1/3, and pi plus 2 pi. So we have the cube root of 4, e to the 1/3 of 3 pi, which would just give us I pi. And then, when k equals 2, we'll have the cube root of 4, e to the I, 1/3, pi plus 4 pi. The cube root of 4, e, we will have 5 pi over 3. Oh, the I. Almost forgot about him. Okay, so now we have these 3, and we can write them in their polar forms. Polar is the cube root of 4. We have cosine pi over 3, I sine pi over 3. And our rectangular, well, we just find out what those are. So the cosine pi over 3 times the cube root of 4, and sine pi over 3 times the cube root of 4. So we multiply all these out, we get 0.794 plus 1.375i. For the next one, we will have the cube root of 4, cosine pi plus I sine pi, which will give us negative 1.587 plus 0i, so we don't have to write that. And the cube root of 4 cosine of 5 pi over 3 plus I sine 5 pi over 3. And the rectangular form comes out to be 0.794 minus 1.375i. And that is all the examples for today.